how the database managers or database designers are converting from the ER diagrams into the tables, right? So next, what is the specialization, what is the generalization, what is the aggregation, how we are going to use these concepts into the real time, how it will be help in a real time. So dear students, before going to the actual discussion of the today concept, we will discuss the outline of the today presentation. So that is a enhanced ER diagram and discussion of with specialization, generalization, followed by the some of the examples related to the these two concepts, and we will discuss the aggregation, and at the end we discuss the mapping ER models into the relation models. That means the how ER diagrams will be converted into the relational models. So I hope every student know what is the ER diagram, because we already discussed the what is the ER diagrams in a session 7, which is the previous one. If you haven't watched that one, I am recommending you to watch that session 7 lecture, then come to the session 8, so that you will understand the clear, right? So next, first one, ER diagram or enhanced entity relationship. So there will be two main important aspects in this one. So first one is a superclass, right? What is a superclass, right? So superclass and subclass. So superclass, we can say it is a general entity. Subclass is a specialized version of particular entity. What is an entity? Entity is any physical objects which will used to store data into the database. So that is a entity. Example, person. So person is a superclass, right? And student employee is a subclass. Why? Because of, as I said, person is a superclass, because of superclass is a general entity. It may be the anything, right? And person is also become either student, either may be employee. So person specialized version is a student and employee. I hope students are clear with the what is a superclass, what is a subclass, right? So now you can see examples here. So person is a superclass. What is the person attributes? Person ID, person name, date of birth, address, phone number, etc. Right? So next, person may be student. If it is student, it is call it as it is a subclass, because of student is derived from the sub person. So that's why we call it as it is a subclass. So and it is a specialized version of the person. So that's why it is a subclass. Similarly, how the person is having attributes, same student also and employee also, right? So what I can say, why it is EER diagram? Because of it is a enhanced version of entity relationship. So what it will do, it will add the some more concept to represent more complex real world situation as existed as a entity ER diagrams. That means that if it is ER diagram, as we already know, it is going to add the some more. It is going to be add the some more complex real world problems to understand better ER diagram. So that we call it as a EER diagram, enhanced entity relationship model. So you may get one doubt, why it is disjoint. If it is person, may be either student or employee, not both. So that's the reason it is a disjoint. We will discuss why it is actual disjoint will come in further classes, right? Right now I hope every student is able to understand what is the differences between the superclass and subclass. Very simple. Superclass means it is a very generic entity. Subclass means it is a specialized version of the superclass, right? So we can take one more example. Vehicle. Vehicle is any vehicle. If I go to the vehicle and further classified into the bike, car, truck, etc. These are the specialized versions. Okay. So next, coming to the inheritance. So what is the inheritance? In general sense, what is the inheritance? Inheritance means some of the properties are acquired from the parents. For example, let us say in real world case, right? So children's will get some of the properties or assets from their parents. So this is the inherited property. So same concept we are going to apply in our IMS subject. So inheritance means subclasses inherit the all attributes and relationship from the superclass. So what we discuss? Superclass and subclass. So, right? Superclass and subclass. So you can say superclass and subclass. So in a subclass, what it will do? It will inherit the all attributes and relationship from the superclass. So right. So now you can see here example person. Person is a superclass. Person ID, name, date of birth are the attributes. Right. So from that student roll number. Student roll number is specific to the person. So what are the attributes coming here? So those attributes will come and join into the student. So that one we call it as a inheritance. So you can see the example person, person ID and name. So student will also have a person ID, name along with is having a roll number. So what is the attributes is inherited? Person ID and name is inherited to the student, right? So this is the inheritance concept. So next categories. So in a categories, first one is a union type. So union type, a class can have more than one superclass. So in a union type, what we say? If it is class, right? If it is subclass, let us say subclass and superclass, right? So till now we discussed the superclass having only one subclass or one subclass having only one superclass. But in union type, it not necessarily one. So superclass, one more superclass, right? So it may have subclass, in subclass having two superclass. So this is the union category. So now you can take owner. Owner is a person, it is a subclass. E may be the person or E may be the company, right? So what I am trying to say, owner, person and company. Owner will be the only one person, right? So what I am saying, simple, don't get confused here. So see this example. Owner can be the one person or company. Okay. So person, company is a superclass, owner is a subclass, right? So this is the meaning, it is explaining the union types, right? So coming to the constraint. So what is the constraint? Constraint is a simple, it is a one condition or one rule, right? First one we can say disjoint constraint. What is the disjoint set in mathematically? A intersection B equal to pi in mathematical. Same concept we will apply in a disjoint constraint. That means that an entity belongs to the only one subclass, not both, right? If I satisfy this condition, A intersection B equal to pi, definitely it belongs to the either A set, either B set, not both, right? So here also disjoint constraint means an entity belongs to the only one subclass, not both, right? So you can see employee either manager or maybe engineer, not both. Employee may be the manager or maybe the engineer. So employee is a superclass, manager is a subclass, engineer is a subclass, right? So that's the reason there it is written D is a disjoint set. So that means that employee may be either manager, either engineer. So not at both sides. That's why it is written disjoint. Right. Next, overlapping constraint. What is the overlapping constraint? If I write A union B, so we will get some X elements. Right. So that means that these are the X element present in a set A, set B. So that is the overlapping constraint, right? So now you can say same example. So person is a superclass, person is a professor and researcher. Person may be the professor and may be the researcher, right? So that's the reason we are saying it is a overlapping constraint. So what is the overlapping constraint? Same time, one person is a professor, one time is a researcher. Same time, one person is acting as a two roles. So that's why it is a overlapping constraint. Next one, completeness constraint. So in a completeness constraint, there will be two categories. One is a total specialization and partial specialization. What is a total specialization? Total specialization is like all will participate. Partial specialization means some will not participate. So you can see the definition. Total specialization, every superclass entity must belong to the subclass. If you go partial participation, some superclass entities not belongs to any subclass. If you take the example, person, right? Person, every person is a professor. Every person is a professor. This is a total participation. All persons are a professors. So this is a total participation. Partial participation means some persons are not professors. So this is the example. So you can see total participation example. Vehicle is a superclass. Vehicle may be truck, car, bike. Right. So it is double line indicates the total participation. Means that every vehicle belongs to the either of category. So that's why it is a total participation. Partial participation means half will follow. Right. Simple example, don't get confused. Every person is professor, is a professor. So this is a total participation. If you cut it every, then you write not every person is a professor. So that means that not every person is a professor means some of the persons are not professors. Some person is a professor, some persons are not. So that we can say it is a partial specialization. Okay. So this is the major difference. So remember one major difference from total specialization, partial specialization. Total it is saying complete, everyone include. Partial means some of the person will include, some of the person will not include. Here persons means it is a entity. Okay. Next, specialization. So what is a specialization? What will do? Specialization is a process of dividing the high level entity into the lower level entities based on their characteristics. So that means that if you take the high level entity, so what will do? There is a high level entity. From this high level entity, we are going to divide low level entities based on their characteristics. So that we call it as a specialization. Journals and doctor. Doctor is a simple, doctor is a generic one. Specialized doctor, cardiologist, neurologist, nephrologist, neurologist, nephrologist, something like that. So that means that, so specialization is simple, it is a one process dividing the higher level entity into the lower level entities based on their specific characteristics. So you can see example here, high level entity is a vehicle, right? So low level entity, it is a car, bike, bus. So you are dividing the vehicle into the lower level entities. So we call it as a, this is called specialization. So what will do? Advantage, it is a remove the redundancy. So what will do? It will remove the redundancy. How? Because it will eliminate the duplicate data. It will eliminate the duplicate data. So duplicate data means I no need to explain. Everyone is aware because of we are already many times we already discussed what is the duplicate data. So one more advantage is it will represent the detailed information. How it will be represented this detailed information? Because of you are dividing the high level entity into the lower level entities. So in a lower level entity we are going to add some more additional attributes, right? So if you are going to add some more additional attributes, so automatically it will represent the more additional information. So comprehensively you can understand better manner. So that's the reason it will represent the detailed information. One more advantage is easier maintenance. How it is a easier maintenance? Because of some of the attributes are common, right? So some of the specific attributes are going to the specific level. So some of the common attributes we can keep it as a one function. The remaining one which is having specific one. So specific attributes will be allocated to the specific places. So as compared to the combining all together, if you are going in specific way, it will be much more beneficial, right? Next one. So I will discuss first generalization. So then we go for the comparison of both, right? So what we discuss specialization. Specialization is the process of dividing the higher level entity into the lower level entity. So that means the higher level entity to lower level entities, right? So this is the specialization. Generalization just simple reverse. So what we will do? Generalization is a process of synthesizing multiple lower level entity into the single level higher entity. So just it is a exact opposite, right? So that is the major difference between the specialization and generalization. So we can see one example: car, bike, bus. So these are the specialized entities. So all these we are combining into the vehicle category. So this one it is a general entity. If you take the specialization, vehicle is a general entity. So from that you are dividing car, bike, bus. So that means specialization from general entity to the specific entity, specialized entity. So whereas a generalization will specialize entity to the general entity. So these are the major difference between the specialization and generalization, right? So specialization we are dividing general to the specific one. So we can say we are coming from top to down. So this is one of the characteristics. Next one entity is dividing into the many. Because of the common to the we are coming specialized. So it will create the special subclasses, add some specific feature. Whereas a generalization is the exact opposite. It is from top to down, generalization bottom to up. So many entities will combine one. It creates the superclass. Specialization will create the subclass, whereas generalization create the superclass. Extract the some common features. So these are the major differences between the specialization and generalization. So now we will see aggregation, right? So aggregation, simple aggregation is a abstraction. Aggregation is a abstraction where relationship set treated as a higher level entity, right? So simple, what is aggregation? You can say simply it is a abstraction. Abstraction means data hiding. So that is the what is the data hiding actually? We are not required to disclose the information. So that is the abstraction, right? So now you can see example what it is doing? Order contain the product, right. So warehouse is supplying the product and same time it having relationship with order and product. So what you will try to understand here, this is the aggregated entity. Why we call it an aggregated entity? Because of warehouse will take the order, same time warehouse will take the order, and from warehouse product will be supplied, right. So warehouse will take the order and same time warehouse will supply the products, right. So one order contains the order and products. So this is the aggregated entity. So you can see an individual order contain the product, like 101 is a product number, contain a product A. Order is there and product is there. A separate entity warehouse is represented as supplied item that aggregated to the order product pair. So very simple. So like for example, if you take the person, right. So person, employee, works, department, right. Employee, don't mind here, symbols are little like employee works in department, right. So take the manager. Manager will manage the employee and department. So like that it will have a relation, right. So you can say simply this only you can take best example, order and product. So warehouse will able to handle this situation. You may get one doubt, sir. Here it is we are saying abstraction is aggregation is a abstraction. How we are aggregating, right? And how data abstraction is happening? You take this entire aggregated product. So this entire thing is treated as a one entity. So this is a one entity. This is the one entity. It is having a relationship, right? So in that way we are designing aggregation. So what is the advantage? It will represent the complex relation. It reduces the ambiguity. How the ambiguity will reduce? Because when you are seeing from top level, it is looking like very simple, but it will not represent the entire data. It will show an abstract version, so that everyone feel that it is a very simple and there is no details or full details are unavailable, and if it is available also it will be written in a form of very clear manner. So in that way it will reduce the ambiguity. So it will improve the database, because of one level by one level it is coming. So it is very easier in real time scenario, because of it is a complex model, and it will more related to the real world situations. So that's why it is a easier representation. Next one. So next, what I am trying to do, I am converting. My aim is to convert from ER models to the table. So for that one we have different rules. There is a 7-8 rules are there. So we will discuss one by one. If it is ER diagram, for example, let us say employee works in department. Let us say this is a one entity, this is a one entity, this is a relation. Let us say rule 1, first rule. If it is strong entity, what is a strong entity? If it is entity contain a primary key, then it is a strong entity, right? So in that case, what we have to do? We have to represent the one table for each strong entity. For each strong entity, we have to represent the one table, right? So you can see example, student is a table, student ID, name, age is will be there. If you want to convert in a form of table, so each strong entity you have to represent one table. If it is weak entity, Rule number 2, if it is weak entity, create a separate table. We have to create the separate table. So there is not much scope to discuss here, right? So what is a weak entity? Weak entity is a depend on another thing, another entity. So that is called weak entity. So next one, if it is one-to-one relationship, so one-to-one relationship is there, then you add the primary key of one table as a foreign key in another table. So you can see one example, person and passport. Person ID is a primary key, let us say. So person ID will be there in a passport table also. I act as a primary foreign key. So this way you can map. That is a rule number 3. Rule number 4. If it is one-to-many relationship, place the primary key of the one side and foreign key in the many sides. So if you take department ID as a primary key, you have to place here department ID as a foreign key. In many places you can keep. So you can see this is a one employee ID is a one foreign key. Something like that you have to create. Next, if it is many to many table, so if it is many to many relationship or exists, then if many to many relationship exist, then create a new relation. You have to create the new relation, right? If it is multi-valued attribute, then create a separate table for that one. If it is composite attribute, then break the composite attribute into the simple attribute. So this is a rule number 7. Like address is a composite attribute. So make that is house number, street, city, state, pin number, etc. in a separate attribute. Rule number 8, specialization. If it is specialization, there are different ways to map this one, right? So like first one is a 3 ways are there, 1, 2, 3. First one, separate, third one we'll discuss, then we'll go for bottom approach, so that separate table for each subclass. So create separate table for each subclass. So that is the one strategy. Second strategy is single table for all entities. You may create a single table for all entities. So that is a one strategy. One more strategy, superclass plus subclass. You may create as per your own. So that means that if it is specialization concept is there, so you may create a single table, or maybe you may create a sub table for each subclass. So this is a one strategy, and one more, you can create super plus sub. So either of the ways you can follow, like this. So these are the 3 ways, all are acceptable, correct. So in this way you can create a tables from ER diagrams to the table, right. So coming to the summary, we have discussed the EER models. So this is the extension of the ER model. Specialization, so it is a top down approach, one entity to the many entities will come. So generalization, it is a many entities will combine into the one superclass. Aggregation is it treats the relationship as a one entity for higher level relationships, right. So thank you for watching my video, right. If you like my content, please subscribe to my channel. Please share to your friends and other people, those who are needy people. If you have any doubt, please write into the comment box. So thank you again. We will meet into the next lecture.